All right, your time starts now. You have 2 minutes to get your header set and everything ready for notes.
Mr. Page 9, right?
Yes, we're on page 9.
Wait, the back of the page, right?
No, the next one. Yeah. For me, it's page 9. Yes.
It's right here.
Leave that one blank. And that one's blank. Take 1 more minute. You have your header and your objectives. I'll fill my objectives in later. As always, you need to header your notes with the lesson title and the objectives. They're projected on the board above my head. Look at the board. You see my face cam? Right above my face cam.
That's right. 4th and 5th and 7th.
No. Yours the other objective. You're not 4th, 5th, or 7th. You're the other objective. If someone wants a birthday recognized, they can let me know. Okay? We'll let that person. No, we'll let that person let me know. Right now, we're doing notes. 30 seconds. Not right now.
It's not my birthday, man.
Okay. No, not right now. We're doing notes. Yes.
So we read the how and the who. No, how.
The what and the how, as always. All right, let's go ahead and get started. We're going to start off with something important. We're going to talk about the anatomy of a radical. They're sometimes called a root, and so you'll hear me go back and forth between the word radical and the word root. Okay? Please know that in math, the word root gets used for other things, not just this radical symbol that we're about to talk about. So I'm sorry if you get confused later. Please invent the time machine, go back in time, and give us a new name for things. I'm waiting for you to make the time machine. It's in it's in progress, so we may have to wait another week or so, yeah? Okay. All right, so here's the radical symbol. As soon as you recognize what the symbol looks like, go ahead and yell out the name.
Anatomy. Oh, square root.
It's square root symbol, yeah. Which is why radicals are often called a root. Now, when you see it from me handwritten in this class, I'm going to put a little tail on it. The symbol doesn't actually have a tail like this. We'll be back after notes.
Please stand for
After.
a pledge of allegiance.
Not notes.
I pledge allegiance.
All right. We're working on the anatomy of a radical. This symbol, I was telling you that I put a tail on it when I write it because when I was in high school and college, I kept doing my radical things wrong whenever I had to work with them. Because either I'd put them too long, and so I'd have more stuff under the radical than I was supposed to, or they were too short and I wouldn't do enough of the things in the radical as I was supposed to. So I learned to start putting a little tail to help me know when it ends. You'll see that for me as I'm writing and doing notes, okay? It doesn't actually have a little tail, but I'll be writing it with it to make it a little more clear where it ends. So far, so good? Okay. This symbol, the symbol that you call the square root, its proper name is a radical. It is a radical. What you typically don't see right now is a little symbol that floats out here. This little symbol is called the index. I have a side note for that. So come over to the side with me just a second. When the index is missing, which means you don't see it, what I need you to do is please assume that the index is 2. More about that in a few moments or tomorrow, depending on how we get through this lecture today. And it'll explain why we call this thing a square root. Okay. All right, the stuff inside. All the stuff inside, regardless of how many letters it is, it could be 1 letter, it could be 2, it could be a bunch of numbers, there could be some addition or some subtraction going on in there. All of that stuff is called the radicand. Like some SpaghettiOs that got canned, this was the radicand. Radicands are allowed to have powers and exponents. So we're going to go ahead and signify that with a letter P to stand for power or exponent. And we're going to be very specific that that power or exponent belongs to the radicand. So power or exponent of the radicand. Yes, sir.
You have to read radicand again if it's like right here. If we went to that, complete the sentence.
Okay, complete the sentence for you? That's fine. Okay, we're going to put a line under this here because we're done with the anatomy portion. Okay, there's the anatomy of a radical. Okay. So those are the parts that we're going to be talking about throughout the lecture for the next day or so. Okay. Move on to the next item, and we're going to talk about the product property. That's supposed to be a P. Product property of radicals. Product is a fancy way of saying what operation?
Multiplication.
Multiplication. So look at the 2 items that you had cut out that you have left from your cutouts and find the one that has multiplication. Glue that in now.
On the right side?
Right here. This is the product property of radicals. Will you pass this on, please?
Cool.
Evelyn.
Okay.
All right. Look at what's happening here. Look at the indexes. The indices. More than one index, I think, is called an indices. Look at the indices. What do you notice about them?
They are have a tail.
The index.
They're the same.
They're the same variable.
They're the same through the
The
whole-
radicands are different, but the index are the same.
Sounds like a lot of E's.
What's the operation happening between the two radical symbols?
Multiplying.
Multiplying. All right, now look at what's happening on the right-hand side.
Now they're together.
What happened to the radical symbol?
They combine.
It combined and became 1. What happened to the index?
Stay the same.
Stayed the same. Nothing happened to the index. What happened to the radicands?
What's that? Oh.
They changed.
They stayed the same, but what are you doing to them now?
You're combining them.
You're multiplying them. You're combining them with multiplication. All right? Let's do an example.
Wow. Loomis.
It's okay. That's not broken. It just means it's run out.
Well, it's because her reaction is.
It's okay. I do that too. All right. Let's look at these two items. The square root of 2 times the square root of 8. As written, we can't do this unless we grab a calculator. And I want you to get to a point where you can try to start doing some of these without a calculator so that you can understand the process behind them. We'll put the calculators back in your hands for these later. Do we know what the square root of 2 is as whole numbers?
What?
1? Really? 1 times 1 is?
2.
2 times
1.
1.
Sorry.
2.
1 times 1 is 1. So the square root of 2 is not 1.
1.5.
It's 2. What does square root ask you?
1.5.
What's the?
Oh, it's 4. It's 4.
What is the square?
Is
Wait.
2 times.
What does the square root ask you?
What's the perfect square?
Isn't it a number squared?
Is
And
eight.
then that's kind of like the answer, so to get it, you just divide it by
In case you didn't hear, she said the square root asks you for the number that when you square it, this thing inside, the radicand, is the answer.
It's 1.4142.
Okay, but I said in whole numbers. What's the whole number?
1.5.
That's not a whole number.
2.
2 times 2 is,
4.
so 2 is not the square root
There
of 2.
cannot be a whole number for 2.
The square root of 2 doesn't have a whole number, so I can't do this simplification right now. I can't do this multiplication as is, because I don't have a whole number here. Because we're going to do it without the calculator. Okay? So we're going to go ahead and use the property that we just talked about, the product property. And I need you now to be specific and say that this is the product property of radicals, because eventually you'll start collecting more product properties, and we need to know what this product property is a property of. Product property says I can mash the two radicals together, and when I do that, I multiply the radicands. Not actually going to,
Put the letter.
I forgot to put the letter, the index. Remember when the index isn't there, we assume it's a 2? Yeah.
Yes, that's 4.
So far, so good?
Yes.
All right. So now I'm going to do this multiplication. So I'm going to multiply 2 times 8, and I'm going to get 16.
And then you're gonna divide.
I'm not dividing. I'm doing the square root. I'm going to evaluate the square root of 16,
4.
which is 4. I've gotten it as simple as I can, and so now I'm done. Make sense so far?
You have to show how much work?
Yes. With all the justifications. Bless you. You must. So far, so good?
Now we're doing divide.
Just by evaluate, what do you mean?
It means I found what the square root of 16 was. Great question. Thank you. All right, let's do another example. Gentlemen, bless you. I'm feeling the same way right now. But this time I'm going to go in reverse. Notice how we went from the left side of our property to the right side of our property.
Now you're going right to
But it's an equal sign, so I could go the other direction if I wanted to. We're going to use that and go the other way. Bless you. Let's look at the square root of 12. Now the directions when you see something like this is going to say simplify. And then they're going to give you a single radical. And your first instinct is to say, it's already simplified. There's only one radical. There's nothing wrong with this.
Now square has to be out.
The thing is that if you can find some number that multiplies with something else to give you 12, and that number has a square root, that is a whole number,
That's you.
I think it's
then you must evaluate that part of the radical. Let me show you what I mean, and then I will say that again. It'll make more sense. Can I rewrite 12 as the product of two numbers?
No.
yeah.
Which ones? 6 and
And
2 or 4 and 3?
Or 12 and 1.
Both or 12 and 1. All three of those options are perfect examples of factors of 12. Our chore is to pick the one that's going to help us evaluate this radical. If I picked 2 and 6, I'd be looking at the square root of 2 and the square root of 6. Does the square root of 2 have a whole number square?
No.
No. Does the square root of 6 be a whole number?
Yeah, no. No.
Yes. 3.
Square root of 6 is a whole number?
No.
3, you said. 3 times 3 is
9.
not 6.
Doesn't.
3 times 2, they're not the same number. So it looks like it doesn't work.
Nope.
So 2 and 6, while factors of 12, don't work for evaluating radicals.
So it doesn't.
1 and 12.
1 and 12, okay. 1 has a square root?
1.
Sure, 1, but we're left with 12 now and we ended up not going anywhere. So while that fits both of our criteria, it doesn't get us any closer to where we want to be.
You're not.
3 and 4. Square root of 3? No. Square root of 4?
2.
2.
Shh. Gentlemen, you're taking notes. 4. 4 has a perfect square root, and 4 is a factor of 12. If you can find a factor that has a perfect root, you must evaluate that. If you want to write that down off to the left, you can. And I'll say it again, and I'll probably write it off to the left when we're done with this example so that you can see it in words. So for this step, I rewrote 12 as 4 times 3. And now here I'm going to use the product property of radicals in order to rewrite it as the square root of 4 times the square root of 3. And as you said, the square root of 4 is 2. So that step is evaluating the square root of 4. And it's going to leave me with 2 times the square root of 3. It can also be read as 2 square roots of 3. Now this answer is simplified. It is considered more simple than where we started, even though there's more symbols and it looks weirder. But it's because you have evaluated the roots of all the factors of 12 that you were able to. And any time that you have a place where your factors of the radicand have perfect roots, like these whole numbers, you must evaluate them. Make sense now? Not really. Okay. Tell me where, can you help me out, find out where that's still confusing? Maybe tell me what you understood so that I can see what pieces are missing.
Why'd you rewrite 4, the square root of 4 times the square root of 3?
From here to here?
Yeah. if you
Because
could
this
just,
is This is in one radical, and I need to use the product property to write it as 2, to show that I'm getting this square root of 4 as 2.
But can't you just skip that because you're already going to get the square root?
Yes, you are allowed to skip it, but you still have to justify it's still there, it's still happening. It's just at that point it's happening kind of behind the curtain, behind the scenes, backstage, you know. No one sees it, but it's still happening. So you still have to justify it. So in the examples, I'm going to show out all the steps, at least when we're starting out. Okay? As we move on, I may skip it and be like, we did it, behind the scenes. Okay. Do you want to see one more example of something like this? Okay. Let's go ahead and do another example of this. In this example, let's look at the square root of, no, I don't want to look at that one. Let's do 32.
That one would be good.
You'll probably need about, yeah. Oh, it's there, right? Okay, cool. So this is one of your homework problems. You're welcome. Yeah. So I guessed this number and it just so happened to be on your worksheet. Oh. Oh. All right. Shh. Here we go. Can we write 32 as two factors?
Yes.
Okay, which ones?
64.
4 and 8.
We can do 4 and 8.
I was like, wait.
16 and 2.
We can do 16 and 2.
It doesn't
I think that's probably the only ones that are going to help us out, maybe.
doesn't
Which one will help us the most?
4 and 8.
Okay, we're going to try 4 and 8. You're saying 16 and 2. Do 16 and 2. We're going to do 4 and 8 over here.
16 and 2 is hard.
Okay, so we're going to do 4 and 8. Okay? So I'm going to rewrite 32 as 4 and 8. Using our product property. Notice how I'm starting to abbreviate the justifications. On your homework, please don't abbreviate. Write them all out. On the notes, I will be abbreviating for space and time. Your homework, you have to write out the full words. Using the product property, I'm going to split the radical. So now I have the square root of 4 times the square root of 8. The square root of 4 is?
2.
And the square root of 8 I have to leave there. The question is, am I done?
No.
Why not?
You have to evaluate.
You are done.
No.
And 3 has 2.
Here? Well, we have the square root of 8.
You still have to break down the 8.
Yeah, you still gotta break down the 8 because there's a square root.
I've still got to break down the 8
But then you
because
have a whole
8
number.
has a factor that is a perfect square. What are the factors of 8?
2 and 4.
2 and 4 are the factors of 8. So I'm going to rewrite 8 as 4 times 2. Okay, I wrote 4 times 2.
What is that? Rewrite 8.
Rewrite 8 as 4 times 2.
That's the answer.
Then again, we're going to use the product property of radicals. Again, remember, on your homework, you have to write out the full words. On your notes, we can abbreviate for space and time. 2 times the square root of 4 times the square root of 2.
Oh, and then you put the square root of 4 times 2.
Evaluate the square root of 4.
Does that give you 8 again?
Evaluate the square root of 4, which is 2. And we end up with this.
That's the front answer? No.
No.
4 is square root.
2 times 2 out here in front, yes?
4.
Is 4. So 4 times the square root of 2. This would be our final answer. Because we can't do this again to 2. Anytime you see a number under the radical where you can find factors that will simplify, you must simplify. Make more sense? All right. Okay. I'd like to introduce the next property. Maybe start one example, and then we'll probably break for the day because we're running close to the bell. Okay?
How times the next one?
Not terribly close. We still got 20 minutes, but I want to give you 10 to work, okay? All right, so I'm out of room on that page. I need to go to the next one. We're on page, for me it's page 10. I don't know what page you're on. If you still have at least 6 lines of space, you should be good. If you have less than 6 lines of space, you might want to consider changing the page.
Add more. 1, 2,
Huh?
9.
I have 10.
I have 9 minutes.
I have 10.
That should be okay.
I'm sorry, what are we doing?
8, 8.
We are doing
I
work.
didn't bring my binder, so I don't know what to say then.
All right, the next property we're going to look at is the quotient property of radicals. Quotient is a fancy word for which operation? Division. So find the one that has division
So 1 dash.
and glue it in. It should be the only one you have left.
What? Where'd it come from? Yeah, it's crazy. What's the
All right. What do you notice?
I noticed I don't have any glue.
But
Hey.
instead of writing both A and
She noticed that from the left to the right, instead of writing the radicands together as a fraction inside the radical, we broke it up and we have 2 radicals, one in the numerator and one in the denominator. Awesome. Do you notice anything else?
They all have ends. Right?
They all have ends. The indexes are all the same. I think that's about all there is to notice on these. But those are really big observations, and I'm really glad that you made them. Let's go ahead and do our example for this one. Let's take the square root of 25 over 4. Now, looking at that as is, your first instinct might be to divide 25 by 4 and get something like, I don't know, 6 point something, and then try to take the square root of that. But if you're doing it without a calculator, it's really hard to do the square roots of decimals. And then if you're looking at the square root of 6, that doesn't have a perfect square root, so it's hard to even guess. So let's use this new property that we were just given, the quotient property. Again, being specific about which property it is. And we're going to split up the radical, the fraction, into 2 radicals. The radical into 2 fractions. There it is. So then our fraction becomes the square root of 25 divided by the square root of 4. Do we know what the square root of 25 is?
5.
It's 5. So we're going to evaluate the square root of 25 and get 5. Do we know what the square root of 4 is?
2.
It's 2, so we're going to get 2 in the denominator. And look, we're done.
oh my god.
I'm sorry.
It's okay. It's okay. That was really cute.
Why?
So the square root of 25 over 4,
What the
language,
Like, see, it's not me this
cut
time.
it off as I said, but
I know. So the square root
That's
of
free, man.
the square root of 25 over 4 is 5 over 2.
What if you can't
That's not a man, it's a
divide
girl.
1?
If you can't,
Or like if 25
No
was,
offense.
or if the 4 was like a 3, how would you write that?
great question. If this bottom number doesn't have a perfect root and it stays with the radical in the bottom, you cannot leave it there. But the process to remove it isn't something I want to talk about yet. Okay?
can we do it on the next one?
We'll do it later. I don't think it'll be tomorrow. But thank you for asking that question because it is really powerful. And I'm not going to expect you to do it yet. It's something that will happen. For sure, Algebra 2, I don't know if I'm going to touch on it much this class period. Okay. We have time to do the final example, which is going the other way. Okay?
Man, it's not on my
Can I do it over here?
You can change. You can do it wherever you've got space. change the page or you can cram it into the bottom, wherever you have room. All right, let's do this one. The square root of 300 divided by the square root of 50. I don't know.
Alright, well, 50 is 25.
It's 25.
The square root of 50 is 25. 25 times 25
Oh,
is
never mind.
300 is 150.
not 50. The square root of 300 is 150. 150 times
wait, no,
150.
no.
What you guys are doing are dividing by 2.
Yeah.
You have to break that habit. Square roots are not divisional things. They're asking what number do you multiply to itself, not what number do you add to itself. All right? All right. Since I'm not really sure, let's go ahead and break out the quotient property.
Isn't it 5?
Isn't it 5, the square root of
Okay,
50?
6 is 30, and then if it's 5 times 10, it's 50. So I think 5 can
I agree that 5 can go and 50 can go into 300.
Yes, they're not
And I
numbers.
think you're kind of close to where we need to be. So hang on to that.
They're not
You're
whole
really
numbers.
there. Okay, so we're going to look at the quotient property of radicals. This time we're going to use it to combine our radicals. So we're going to end up with the square root of 300 over 50. And now we can do some division, can't we? 300 divided by 50 is? As you were saying that 30 divided by 5 thing, this is going to be 60.
I mean, okay.
So far, so good? We're okay so far? All right, square root of 60. Is that as simple mathematically as we can make it?
No.
Does it have a factor that has a perfect root?
No.
Which factor?
10. No. No, it doesn't. 5.
5? So 5 times 5 is 25. 25 times what gives you 60? Not 3, that's 75.
35.
35?
7 times 5.
7 times 5?
35, and then you add that.
I don't know, I'm not good at math.
60.
You add what?
16.
16. 16 times what gives you 60?
5 times 6 equals 30, and 30 times 2 equals 60.
12. It's 12.
Okay,
It's
but
12.
that's 30 times 2. We want 30 times 30.
12 and 5.
Or 5 times 5.
12 and 5.
12 and 5?
7.75
12 times 5 is 60. What's the square root of 5?
Math.
What's the square root of 12?
2 and 30.
It has to be the same number, doesn't it?
4 and 15.
It's got to be the same number.
It's got to be a perfect square.
Has to be a perfect square. You're looking for the same number multiplied giving you a number. He said 4 and 15.
6 and 10.
You had said 4 and 15. Does 4 have a perfect square root?
Yeah.
Yes, 2. And that's all we need. We don't care about the other one right now. As soon as we find one that works, we're going to do it. So this is a rewrite 60 as 4 times 15. We're mixing the two properties now because can you see what we're set up to do? Which property was this? What was the fancy word for multiplication?
Product.
Product. Which property allows me to break the radical at multiplications? Which property allows me to break radicals at their multiplications? The other one? Flip back. Property. The product property of radicals. There it is.
Next question.
Yes. El mismo que ya hicimos.
No, what does it say?
¿Cuál? ¿Aquí?
Yeah.
Review.
Rewrite.
I mean rewrite. Oh, I put review.
Gentlemen, if it's not what we're doing, it has to stop. And that's 3. So we will talk at the end of the class. Evaluate square root of 4 becomes 2, and we're left with the square root of 15. Does 15 have factors that are perfect squares?
3 and 5.
3 and 5, but
Those aren't perfect.
those aren't perfect squares.
No.
Yeah, I can't think of any either. So that means that we're done. The moment you get to the point where you can't find any more, that's when you're done. So this one required us to mix our properties. But you did it.
Miss, isn't it kind of like a tree factor? Like, you know how we
Exactly. Yes. You can use your tree factors to help you out with this. I'm so glad you're pulling from before. Any questions on this?
Are we gonna have worksheets on?
Yes.